This is a video on how to find the area under a curve, or you could also consider it a proof of the fundamental theorem of calculus. So, I have an arbitrary function. Do you know what that means? A function, for every input there's a unique output. So here is my arbitrary function. It's not a straight line, it's nothing. It's just, it could be anything, it could be all squiggly. But for every input there's a unique output. This is f of x. It's nothing and it's everything. It's just an arbitrary function. So, okay, I've set this up for us. These endpoints I'm going to label as x1, as xn. These are specific x's on the x-axis. This is the y-axis, or you could think of it as f of x-axis, because it's just the output axis. This is the input axis, this is the output axis. Okay, so I've set that up. And another piece of information we need before starting this video is what a tangent line is. So you put a line through a curve and keep putting the line through the curve until you're just at the point where it goes through the end of the curve. That's the tangent line. So here's another slope. Here's a tangent line to it at one point. And here's a tangent line to it at another point. So another tangent line for you. So here, let's think about tangent lines and what I can represent with what. I'm going to draw a point. I'm not going to draw a point. I'm going to draw a line. This is a line. This is a line. These are points. So, see, I just connected this point to this point and drew a line. And this is point A. It's point A plus B. So, do you see that no matter what my function looks like, if I draw a point between A and B and A plus, or if I draw a line between any 2 points on the function, there's going to be some value right here where if I take the tangent line to the function, it's going to be parallel to the line I drew. Do you see that that's always going to be true? Just try and concoct some arguments against it in your head if you don't think it's true, and you'll soon see that it's always going to be true. That if I connect 2 points on a graph, there's some part on a function, 2 points on a function, there's some part of the function whose tangent line is parallel to that line. So I'm going to call that line that has to exist between any 2 points x star. This point is x star. The line's not called x star. The point's called x star. This is f of x star. So what does the slope of this line, how can I write that? What is the slope of that line? And if you were to ask me that question, I would answer right away that the slope is f of a plus b minus f of a over a plus b minus a. Do you know what this is? This is rise over run. How much it's going down divided by how much it's going this horizontally. This is the slope. Do you see that the slope's going to be bigger if it's a greater difference in height? So I'm going to define f prime of x star. Or not of x star, but f prime of anything. Just putting a prime symbol over a function. What does this mean? It means take the tangent line to it and tell me what the slope is. And we know the slope of this and this are the same, so I can do that. A slightly more rigorous way of expressing what I just expressed, like if I wanted to define f prime of x, I use this symbol, 3 lines to define it, as f of x plus b minus f of x over b. You're going to say, hey, wait a minute, this is the same thing as you did right here, right? A and A cancel out. So why are you writing this again? And I'll tell you, it's the limit as b goes to 0. So what that means is that this length here, a plus b minus a, this length is b, that length is going to 0. This length right here is going to 0. So it's going to be the tangent line to the point, the curve at this point, because it's like you're connecting 2 points together that are just really, really, really close together already. So it's the instantaneous tangent line. And I'm going to reference this later, so I really want you to remember it. There's definitely some point x star between 2 points on a function whose tangent line slope is parallel to the line if you drew between the 2 points. Okay. Now I would like to graph f prime of x. Here is my axis, and so this point on f of x, x1, so I'm going to starts at x1 just like f of x does, and if you put x1 into f of x, you get this number. If you put x1 into f prime of x, you get, say, this number. And this happens for all the variables till xn, my endpoint, which is the same on the other function. This is the same length as I had on the other piece of paper. This is the same a I had. This is the same a plus b. This is the same x star. And this is f prime of x. This isn't f of x anymore. So, do you remember that we found this out? Okay, so now I'm going to take this number, whatever this number is. You can probably see that it's b is a, and a minus a is 0. So f prime of x star, if I multiply both sides by that number, I can say that these two amigos are equal to this. Right? You see? It's the same here. Just multiply both sides together. So, what does that represent here? It's times the difference, b, but it's really a plus b minus a equals f of a minus f of a plus b equals f of a plus b minus f of a. So this is saying that this height, this is f of x star, this is supposed to be a star, I had it as a star before, see? There's a star. F prime of x star, so that's just this number, times b, that's just this width. So what's that? That's the area right here of this box. That's what that represents. Is equal to big F of a plus b, big F of this point, minus f of a, this point. And what I'm going to do now is I'm going to sum up all of here, wait. First, this is what I'm going to do. I'm going to say there's more points on the graph now. x2, x3, x4. These are all like the same distance away from each other, and they keep going on and on, x5, x6, x7, blah, 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 until xn minus 1, xn. So this will be xn minus 1, xn minus 2. Don't try and count how many there are. So, what I'm going to do now is I'm going to sum up all of these areas. And I'm just going to write this again. Times the difference. So wait, before I get into this, I just want to say one more thing. Here in my picture, this is really wide, but I'm going to be taking really thin slices. So it's just going to be a super thin slice, and there's going to be a lot of ends. So conceptually, keep that in mind. So anyways, what does this symbol mean that I've written right here? This means there's going to be some eyes, and take this whole expression, this number, what this all represents when I is 1, and add it to what this all represents when I is 2, and add it to what this all represents when I is 3, and keep going until I is n. So x sub I plus 1, so x sub, when I is 1, will be 2, minus x sub I. Okay, that times f prime of x star, which is the value we know is in between any 2 points on the graph, and that the star is referring to whatever's next to it, which is these two guys right now. And that's going to be equal to f of x2 minus f of x1. See how I did this? It's not for all of them, definitely not, but when I is 1, then this is times this is the first endpoint, this is the second endpoint, so we can do that. This is just, I've been showing you exactly how this works, and we're going to do it for all the i's. So this is when I is 2 now. Let me do it when I is 3. And I keep doing this. It's been plus a bunch of terms, plus f of xn minus f xn minus 1. So, do you see that this 2, f of x2, and this 2, they're the same number, but this one's minus and this one's plus, so I can just cancel them out. And the same happens for the 3. F of x3 cancels out. Just think about it, or believe me that f of x4 will cancel out and f of xn minus 1 will cancel out. And at the end of the day, you're left with f of xn minus f of x1. And I want to take the limit of this. There can be however many n's I like, right? Because it's just going to be the endpoints at the end. So I want to do it as n goes to infinity. It's not at infinity, but it's getting there. And do you remember I defined this as the difference is going to 0. B goes to 0. Well, that's the idea. I want this distance to be going to 0 too. That's kind of what I mean by this infinity. Like, this distance is shrinking and this number is growing, the number of ends, but it's the same endpoints, like the same pattern of a curve shows over it. So what I did here, what this represents now, since these are all super, super, super small, so it just gets like a little bit of math juiciness out, is that this area from this endpoint to this endpoint under the curve f prime of x, this area is going to be f of the first endpoint minus f of the second endpoint. Not this f of x, f prime of x, because that's not f of x. I'm talking about the f of x that we were talking about before. Don't you remember? This f of x, so just that endpoint minus that endpoint. That's what that means. It means the area of this is equal to these two endpoints subtracted from each other.